Well, hi, good morning. Thank you so much for joining me here in my shop. So yesterday didn't go all that well for me in here. Somehow I got thoroughly turned around looking at this chart, and I think today I think somehow I have a clearer vision of this coming in here. So the question is, how come on the broadcast band the radio seems to work really well, but on the shortwave it doesn't seem to work at all, or barely at all? What is the difference, and why is everything dropping off like that when you switch to shortwave? So I spent yesterday looking at the surprisingly complicated arrangement in here, and I think it just became a little bit too much for me, along with many distractions I had yesterday. So I came in this morning and I just said to myself, look, the shortwave antenna signal has to get from this point, has to get to this point. When you flip the shortwave, this switch flips. This tube gets its grid supply from this blue line here, and all of this just sits here. Maybe it's doing something, but it's not doing anything that affects the rest of the radio because it's open circuited here. So if we work our way back, we just follow the blue. It has to be this somewhat circuitous circuit. Not there. Up here. Oh, getting confused already. So what I think is happening is I think I got it. The signal's coming in on the antenna, going through this coil and going to ground, to the chassis. That sets up a field here, energizes this guy. This guy would normally drive through here and eventually make it over to this grid. But with the switch open, can't get all the way through. So whatever's happening doesn't matter. But there's also this wire coming out the back. This wire comes down. This switch would be thrown. I got it wrong again. This wire. The blue line, Jim. So this wire can intercept the signal that's been transferred from here to here. At this point, bring it down, bring it around. This switch has been thrown, so it's closed, through the capacitor, up here and around and over to the grid. Now, what is this other line here? This large resistor, 1 megohm, is the bleed resistor, if you like, on the grid circuit to make sure charges don't build on it. And as for the bias, the AVC is not applied to this tube. I could have sworn a cat was just climbing up my leg. Aha! There he is. That's the guy. Okay, Bert. Back to what I was doing. See, now these are the distractions that destroy my time in here. Okay, so the resistor and this wire goes back to B minus along here. So this is the I forgot the right grid. I forgot the proper term for it. The resistor that's going to bleed away any charge that might build on the grid otherwise. And the bias for this tube, it must be kind of self-biasing. Not sure about that, but how else can it be biased? So that's the situation. It is this weird circuitous thing going on. Now, why wouldn't it work? We're cutting out all this. We're skipping over to here. So I think what I want to do is, it could be this capacitor, it could be open, or this one could be open. I think what I want to do is feed in a signal and kind of work my way back through here and see what happens. So I want to feed a signal right in at this point, right onto this grid of A7. That's my goal. Feed in a shortwave radio signal, like maybe 10 megahertz or something like that. Tune it in and the like. I might even just start at the antenna. Like I don't know. Gotta think a bit about it. Okay, I'm a little more on track today. Okay, so here's what I'm going to do. I'm going to run the radio from an antenna, listen to it on the broadcast band, and therefore know it's working, and then put a shortwave signal in using my signal generator here. And we'll see what happens at that point. Okay, so I have the outdoor antennas connected, plugged in, switched on. Here we go. Now the radio is connected to a good outdoor antenna, so it's going to operate. It's missing its own loop antenna. That's a lost thing. Like a lot of these radios, they have the antenna on the back. The back gets lost. The antenna goes with it. People don't understand that the antenna on the back of the radio is part of the tuned circuitry of the radio, and so it's a big loss. Let's see what we can get here. So despite the very strong interference that's here, we can hear a station, so radio's working. Okay, now we're going to switch to shortwave. And then we're going to switch from the antenna to my signal generator. My signal generator will put out obviously different levels of signal, including more than you'd ever get from an antenna, if I wish to do that. Just sounds totally dead. So we're tuned somewhere in the middle of the band, or we're in the middle of the band somewhere. That puts us around 11 megahertz. Okay, 11 megahertz. So my signal generator is set. Let me just calibrate it here. Whoops. So I'm just calibrating the output on it right now. So this is, right now, the signal generator is transmitting a very strong, like strongest antenna signal you would be likely to get over to the radio. But look, it's at the IF frequency. We want it up around 10. Okay, so I'll turn the volume right up. Double check. Definitely connected. Okay, and I'm going to tune it this way a little bit to make sure it's well above 10 now, because 11 was roughly in the middle, so this might even be up around 12. So there we are. So again, this is a very strong signal being sent in here. A strong, typical strong antenna signal would be like that. This would be probably what it's getting from the antenna that I was using. And there's nothing. So that's probably the situation here. It's not that it's broken, or it's there's no path for the signal to travel. There is a path, but it's weak for some reason. Possible it's weak because of some kind of alignment thing. I kind of doubt that. So from here I want to move the signal generator right onto the grid. Like if I understand this right, the antenna signal, it's coming in, transforming to here, traveling here, traveling here, traveling all around there somewhere, eventually getting up here and making it to the grid. So I'm just going to skip all this and feed the signal right in on the grid here. The grid is pin number 5, I think. I'm going to double check. So it's grid number 4 that's being used in this tube. This is an octode. So grid 4 is pin 6. Wow, okay, I got 5 in my head. Good thing I checked. 6. Pin 6. So we take a look under here and we count. This is the tube. 7A8. And pin number 6. So here's the key. So we go 1, 2, 3, 4, 5, 6. This is 6. Oh my gosh, it's not what I thought it was. And this wire's going over to the switch here. A wire to the switch. I'm just going to double check. It's not really the case. We come out on grid 4. 1, 2, 3, yeah, 4. Straight to the switch, of course. Yeah, switch right there. Yes, yes, yes. That's it. So that's where I want to put in a signal, or I want to listen for the signal being there. I think I'm going to put in the signal there. I'm going to grab a capacitor. Here. Pin number 6. Pin, I shouldn't have any voltage on it, as long as I'm not mistaken. I don't like this. Okay. This is attached to the chassis, but it might be better attached to the B- at this point. I don't have the antenna connected, so there's only one ground coming over. It's from the signal generator. We'll go ahead and leave it as it is. What do I expect to have happen now? I expect to hear this. Wouldn't that be right? I'm feeding in the signal that the radio is tuned to, feeding in at that same low level over there, and it's not audible if I turn the volume down. Still not audible. Okay, so we'll tune the signal generator back and forth a little bit. So it's there with a it's got a hum interference, and I'm sure it's from this connecting to the chassis here rather than the B-. So if I didn't want to connect to the B-, yeah, let's do that, but I'm going to turn the radio off while I do it. That should be a little better. Back on. Now the reason I can do that, not too much concern, is because I have the radio plugged into an isolation transformer, so it's not plugged into a grounded outlet. So neither of these wires are in any way grounded, tied to the power system neutral or anything like that. It's okay. So now we turn it back up. It is up. Oh, come on. So now the tone is nice and clear. It doesn't have a hum voltage stuck in it. So this is with the reduced signal. Like if I move this to the antenna, we should pretty much hear the same thing. I will do that. Volume's way up. We're on the antenna now. I don't hear it. Some tuning things may have happened, so I'm going to shuffle this a little bit. So it's right there. You just barely hear it. Okay, and we'll go back. Hear the volume. A little bit louder. Tune it. Yeah, it was tuned properly. So a little more signal, not an awful lot. This is a very strong signal being put onto this tube. So what could be wrong beyond there? After this tube, the signal's been converted down to the IF frequency to run through the IF transformers. So, weak local oscillator? If you have a weak oscillator, you get a weak output. Well, yeah, I guess we could look into that. That's not hard to look into. Well, we're putting the signal into here, and I have it switched to shortwave. So there's a connection here. So this is in the circuit. Would there be any reason to think that having the stuff left in here is somehow dragging down the signal? Only if something's like leaking the signal to ground or to the B minus or whatever. I don't. Well, I can flip the switch and see what happens. I can just flip it. We'd still be pumping the same signal in here along with whatever's coming out of here. You have nothing hooked up to the antenna, so there wouldn't be too much. Flip it. That'll disconnect it from here. And I don't know. Let's do it. Let's just do it. See what happens, just in case. Turn the volume down. Nobody home. That could be, again, a little frequency shifty thing has happened here. Let me just... No. So ditting that for whatever reason. Why so weak? So a weak local oscillator would be the next thing to check on. Okay, that's the next thing we'll do then. Okay, so here's the SDR, and it's tuned to the same range as the radio, and you can see this large signal right here. That is the local oscillator, and all these other things are bizarre artifacts coming from either the SDR itself, perhaps from being overloaded, which I don't think is the case right now, or it's coming out of the radio. So that's a local oscillator. Why is it jumping like that? So I'm kind of swinging the radio back and forth, so maybe we got something a little loose here. Don't know exactly why it's doing that. I'm just rotating the okay, we won't worry about it at all. Just want the oh, let me just move this. Sorry you're not seeing what I'm doing. I'm just straightening up the wires here on my bench a little bit. Okay, there we are. Now I'm going to tune the radio a bit, and you'll see the local oscillator move rather rapidly. And if I stop here, it's about 12.75. It take off 450 right around 12.3, which is roughly what the signal generator was sitting at when the radio picked it up. So that all makes sense. So there's a local oscillator. Now I remember before when I did this, I got a stronger local oscillator signal on the broadcast band, but just the pickup coil was in a different place. But it was up around 30 or 35. This isn't much short of it here. And I'm sure if I move the pickup coil around, I can get more. Let's go to both ends of this band, and we'll see what the difference is in the signal strength. I'll try not to move the coil here. Let me just put something to hold it more in place. Okay, so I'm in the middle of the band right now. I'm going to go to the low end of the band, and then we'll have to retune the... Okay, tell you what I'm going to do. I'm going to switch cameras here. Okay, kind of get a better idea what I'm up to. So we've tuned it way down, and the bottom of this band was, what was it? Was 9, wasn't it? 9 megahertz. So we'll go down there. 9 megahertz. Okay, somewhere in here should be the local oscillator. Maybe it's this guy right here. So I will tune upwards. It's moving upwards. Okay, look at the display. Someday I will understand completely what is going on here. But I think that's a local oscillator, and if I set it right on the red line, that's a foolish thing to do. We will prove this. I will set this to 9455. That doesn't quite make sense. The local oscillator is probably above the target frequency, so we really want this to be 545. I think that puts the local oscillator at exactly 10 megahertz. If I tune the radio, so what am I doing here? So 945. So tune. Oh man, that's just not at all what I want to do. And once again, not enough coffee this morning. So I just want to prove the local oscillator is what it appears to be. Let me find out where the radio is tuned at the moment. Down around 9. Good luck. I do not have the signal generator connected. I do not have any other grounds connected. Signal generator. I'm going to stick this right on the antenna. And this guy I want to put on the ground. Am I too scared to do it this time? Yep, power off. Okay, power on. There we go. Sometimes just fooling around, you may stumble on something anyway, so a little bit of fooling around doesn't hurt. Okay, and 9. Okay, so that again, the signal strength here is the strongest signal you'd ever get from an antenna. That kind of level. And the volume is up full. This thing should be screaming out, but it's not. So now we know the radio is tuned to 9780. 9780. So if we go to 97, so I'll put this down here. So we did 9750 roughly. It sounds like it should be in here. Like if you add 400 here, you'd get something in here. Did I just tune the radio a little bit. Oh my gosh, look at everything moving around. Huh. So the biggest one is down here. Maybe it's below. Because let's see, this frequency is 938 and the radio's tuned to 978. That's 400 between it. Let me move this up a little bit. Is this the local oscillator here? What do you get when you add 455 to that number? Okay, I'm just not going to trust my brain. That number is 9385. Oh, you can't even see it on the screen there. Oh, I'm so sorry about that. Let me fix that. Okay, back to what I was doing here. 9385. 9385 plus 455 9840 is where the local oscillator should be. 98. No, that doesn't make sense at all. What I just did, that doesn't make sense. Radio's tuned, let me get this straight now. Radio's tuned to 9780. So we take 9780, add 455 to it. Local oscillator should be at 10.235. 10, so I'll move this red line there. 10, oh, that was dumb. Yeah. 10, 2, 3, 5. It should be here. It's nothing there. It's nothing there at all. So what do we go the other way? We go the other way. So we go the other way, 9780. 9780. And then we're going to take away 455. 9325. Okay, so look at 93. Well, we just 932. There's nothing there either, except there's this. So I'm gonna move the pickup coil a little bit here. Yeah, it sure looks like that's the local oscillator. You can get a pretty strong signal there. So there's a local oscillator. I thought I proved the IF to be 455. What's happening here? If that's the local oscillator, then we take that number, add 455, tune the radio there, we should hear it. Take that number, 9384. 9384, add 455, 9839. So if I dial up 9839, we should hear it, but we're hearing it at 9780 right now. This is crazy. 98. No. So what is this telling me? The IF is way off? I thought I proved the IF to be correct. So something's gone wrong here. Something's gone wrong, and it could be me. Could be me. What to try next on this? Wouldn't mind being a little more certain of what's going on here. I say we repeat this, only we do it at a simpler frequency. So I'm going to tune the radio to 10. Right now it's at 9.7. 10's going to be up here somewhere. Wow, is that hot? That is hot. Is not the light on? The light is on. Okay. It's not so hot I can't put my hand on it. I'm talking about this here. So it's actually not as hot as it was. Good. So we want to get in 10 here. Get the radio tuned to 10. I'm way past it. This will be a little clunky to do. Huh. Maybe it's just an alignment issue. So that's 10. When I set the radio down, the capacitor gets knocked a bit and retunes a touch. So right now the local oscillator's got to be, let's look. It's got to be either at 10. It's either got to be here, 10, 455. I don't see anything there at all. Or it's got to be down below at 9. There's nothing here. 9. 455 should be here. Right here. This is it here. Great big strong signal here. Well, I don't think it's a weak local oscillator. I think we can kind of figure that that's not the problem. Let's go up to the top of the band now and repeat the same thing, only just look at the strength of the local oscillator. We'll go way up to the top. Top on this radio is, was it 18? 15. 15, so we're somewhere up around 15. Okay, so we'll find it here. 15. It's much louder, much stronger. And then slowly fixing it just by fooling with it. 15. So again, there's a really strong signal being put in this radio. A more typical antenna signal would be like this. I can still hear it, but it's very, very faint now. And really, a radio like this should go much lower yet. So I'm sure it's weak. We'll look at the strength of the local oscillator. Hopefully I haven't moved the pickup coil. I probably did. We are up at 14. So we should find out just above 14 megahertz, I believe. Just above 14 megahertz. So, well, there's something way up here at 15 and something right in here. So this is 13,780. And we're tuned to 14.6. What? No. I thought... Totally lost my mind here. Yeah, we just wanted to find a local oscillator and see the strength of it. I think it's pretty apparent. It's, if anything, it's stronger. Well, is this it? So I'm going to move the red line off so we can see it there, and then I'm going to tune the radio a little bit. And it's zooming around, and other stuff is zooming around too. If I'm tuning the radio down, which I am, that signal should be going down. Well, it's way over on the right there. This is usually not so trying a thing. I think it's this one now. So if it's that one, that's at 14,800. That's a 14,900. Subtract 455. Oh my God. So we're tuned to 14,500. So 14,950. Now see, a 14,900. Did I not check? I thought I checked the IF on this and it was fine. Let's do that. I'm going to pump through the IF frequency here because we're hooked up to the antenna. Yeah, it should work. Maybe I didn't do this. So where? Just coincidence, happened to be right there. I don't hear anything though. Are you kidding me? Huh. It looks like it's 400. Well, I guess I mistakenly thought I had checked this earlier. All indications are the IF is tuned way off here. Oh my. But the broadcast band works really nicely. Well, it can be tuned to the wrong frequency, but be tuned up at the wrong frequency. Oh my. Okay. I think we have to just turn our attention to that. Okay, I think I'm ready here. So I have this voltmeter connected to an AVC point in the radio, actually the input to the volume control. And I'm thinking there's going to be a DC voltage there that's going to reflect the signal strength coming through. I'm going to show it up on the meter. And I also have the signal generator set up. It's still at 400 hertz. Let's turn on the radio and see what happens here. So this should come upscale a little bit if there's a signal being processed by the radio, and that would include a little bit of noise. So this did come up a tiny amount. Wow, okay, that's a little bit of a strong hum there, but we won't worry about it. It's probably from the way I've got the equipment connected, because I have not connected the negative return on the meter here, because I'm thinking it's good enough to have the general ground in place on the radio, if that makes sense to you, on the B minus. We'll see what happens here. So we need a signal here. It suggests we do this on the broadcast band for some reason, with the capacitor closed. It's closed. Where'd that? See, I just had it turned up a lot before. So there we go. We see a little bit of a voltage here. If we tune around, that should have caused this to jump. Okay, so I'm thinking I've got to connect this. Okay, to do that, so I did not want to do. I have to go up here. So I don't want to put two grounds in two different places on the radio, like the chassis and the B minus. They got to be together on this. Okay, I don't think I want that big clip lead in there. So what I'm going to do, I'm going to separate this here. Connect this to the B minus. This is the connection for the AVC or the not necessarily the AVC voltage, but a DC voltage like the AVC voltage. And now I can put this on here. This might make things work a little bit better. Power back on. Let's see what we get now. Feel a little better having this connected. So as we hit a signal, this should go up. You can see it move. Oh yeah, a little wee bit. That's enough. That's enough to do it. Okay, now we want to turn the volume down a bit. Close the capacitor as suggested. Incidentally, one of the alignment steps is to make sure the pointer is lined up with the check marks that are on the face here. The first check mark is right there, and it's aligned up right on it. So the pointer's in the right place, but that doesn't matter at the moment. Okay, let's find out what happens here. Something should have happened there. Why did we get nothing out of it? I don't have the modulation on. That's probably why. Ah, it's right on. Like, oh, it's right on. It's right on. Ooh, what's going on there? That's a little weird. That's definitely a little weird. Yep, we got a strong signal here. And another one here. This one actually, So this is the 400 hertz one, and I'm just gonna put the camera here so you can see it. That's 400. That's going below 400. Okay, back up through 400, above 400, 420, 430, 440, 450. So at 455, that's what you get. And down at 400 is this. There's even something right in this area here. Huh. So I think this thing is just way out of whack. It's just way out of whack. Let's see if we can bring it into whack here. So so the assumption is these two transformers, one of them's tuned to 455, the other one's tuned to around 400. Something like that has happened. And we're going to try to figure out, first of all, which ones it is that is tuned where. So I'm going to put the signal generator at 400 here. My assumption here would be, if I adjust the 400 one, we'll see a big change on the meter. If I adjust the 455 one, we won't see much change. And that's how I'll identify. I notice the screws are down low in here, and they're right up near the top on here. So we're going to start with this one. So that's changing it quite a bit. That's very tight. So this is changing that one quite a bit. Now we'll try the other one. Maybe we'll find the same thing happens here. Same sort of thing. What are you doing here, Mr. Radio? They all seem to be peaking on this 400 thing. Well, let's just start moving it to 455. We'll see what happens as I try to do this. So I'm going to take this up until we can't hear it. Way up here. Okay, and now I'm just going to try to make adjustments to make that stronger so we can hear it again. Don't really worry about the meter right now. Okay, I don't have the best feelings about this. Okay, now we'll take this up to higher. Wow, like you can't even tell the difference. It's a huge broad bandwidth. I think we'll fix that. That's 455. We'll do it again by ear, mostly. Watching the meter now. Okay, next one. Okay, next one. I think there's something weird going on here. And the last one. I don't know why. Phone's ringing. Okay, I'm back. Let's see. So I think I've now adjusted this to 455, but I got this weird feeling that there's something more going on here. So let's do the sweep thing. We'll see what happens. Oh, where'd that come from? There is something strange going on here. Now, is it that one of these transformers, one winding is tuned to that? let's fool with it a little bit. So we've got it on 519. Apparently there's a signal there doing that. Oh, wait a minute. This could be coming in. Oh, it's coming in through the tuning. Yeah. Man, the radio was tuned to 519. That's what happened there. That's why I'm picking that up. Good thing I checked for that. So now if we repeat this, what I did was I basically presented the radio with a receivable signal. Kind of low, but so go back down. Ooh, what was all that malarkey? So there's a nice clear signal here at 455. And you can see the AVC is, the voltage has gone down, the sensitivity's come up, we're hearing noise. And then along comes this thing. Let's go higher. All kinds of crap. Oh my gosh. This goes on. Well, of course, I'm tuning into the tuning range of the radio. Don't you're fooling yourself here, Jim. Contrary to what they suggest, I'm going to tune this radio up. Let's say here. So there's the 455 thing. What's this? Where'd that come from? Okay, I'm going to just tune the radio. Huh. Maybe that's a harmonic if we think about it long enough. That's probably what that is. Okay, so did I manage to do this correctly? Or is there something more going on? I think there's something more going on. Well, let's try it on an antenna. We'll see what happens. So I'll take off the signal generator signal and I'll put on the antenna. Oh boy, what should I do here? This is another ground. All grounds got to go to the same place. So I think I'm going to have to ground it onto the B minus, but that's not proper for the antenna. So we're going to take everything off the B minus connection here. I better take that off too. So now there's nothing tied to B minus. I can put the antenna on the way it's intended to go. Picking this up. Did I put the antenna or did I put the signal generator back? I put the signal generator back on it. There we go. Let's put the antenna on it this time. Ground. Broadcast band. That'd be 590 there.
To the lower level of quarterbacks, it's mechanics. It's
Ignore the interference.
Yeah, we can do it.
She's working great. Okay, so the AM didn't suffer at all from what I did. We'll go over a shortwave. Downward 9. So anywhere on here we might pick stuff up. And then again, nothing. Okay, we'll put it in the middle. And we'll say back to the signal generator. Okay, this time signal generator is going to be, so it's the only thing connected, chassis and antenna. So we're somewhere again around 11 megahertz. 11 megahertz, eh? There it is. Okay, volume. That's the volume full. Back a little bit. Well, I think it's better. Eleven oh 68. Now, do we pick this signal up anywhere else? Didn't hear it. That's it. So this is the image down here. Just about as strong. Local oscillator is below. Is that the problem? The local oscillator should be above? Is that what's happened here? So we got the radio aligned on the image. Need to find out where the local oscillator should be relative to the target signal. And there should be a hint in the service manual somewhere. So I'm going to go look. Okay, so here's the alignment instructions, and I'm looking somewhere in here for a hint as to whether the oscillator is above the target frequency or below. And there is a hint in here. So the technique they suggest is right here. So to accurately adjust the high frequency oscillator compensator to the fundamental instead of the image signal, turn the oscillator compensator to the maximum capacity position. From this position, slowly turn the compensator counterclockwise until a second peak is obtained on the output meter. Adjust the compensator for maximum output at this second peak. Well, that doesn't quite help, but that's how you would do it following their instructions if you didn't have the equipment or the wherewithal to figure it out. But look at this next statement. If the above procedure is correctly performed, the image signal will be found much weaker by turning the signal generator dial 900 kilocycles above the frequency being used on any high frequency range. What? Above the frequency being used on any high frequency range. I don't know what they mean by this, but what they're saying is the image is above the target frequency and the local oscillator is in between. So the local oscillator is above, but on this radio it's below. It's misaligned. I think that's what I could figure out from this. The aerial pattern must be adjusted to maximum by rolling the tuning condenser. So usually they use the word rocking here. Here they've used the word rolling, rock and roll. The tuning condenser. If the two signal peaks occur when two signal peaks occur when tuning the pattern, adjust the maximum output to the first signal peak. So probably what's happened is they've got the oscillator on the wrong side, but they've adjusted this on the correct side, which is now the wrong side. So they've strengthened the image with this. That's probably what's happened here. Okay, well, you know what? It's late in the day, so and I got cats here that are trying to entertain me, and I think what I've got to do is I got to go pay attention to these guys. They're looking for fun. So I'm going to leave it right where it is now, and we'll sort this out tomorrow and get the alignment correct, and probably the shortwave band will come to life. That's my guess. Okay, well, thanks a lot for watching, and we'll just keep chugging away on this radio tomorrow. See ya.